The next thing I want to do is scatter plots. Before we do scatter plots, let's take a 10 minutes break, and no more than 10 minutes break, guys. I know that it's not yet a 1 hour, 2:30 to 3:30. Actually, it's about more than an hour. But let's take no more than a 10 minutes break, and then we'll change topic and do scatter plots. But by now, you're familiar with how we do things, so brace up for it. We'll gradually move faster. Guys, are you comfortable with the fact that I didn't make you do it? Or would you prefer that we do it right here?
I think it's fine. Just post the library.
All of these books, yes, they will all be posted. They're actually there on the website. I just have to make them visible. So as soon as the class finishes, all of these notebooks will be there.
Okay, great. Thanks.
Class board.
Okay, thank you.
Right. And guys, use it as a base. Actually, what you are seeing here, if you Google it up, you'll never find information so systematically presented or carefully done. Most of the time, engineers are terrible. They have very low patience for data visualization. They'll tweak it a little bit and they'll be happy and move on. Right? But visualization matters. I hope the one lesson you learn is both aesthetics and explainability of a visualization matters. So 10 minutes break, we'll meet at 3:50. Usually when people are here, some of you are here, I ring a bell to announce the end of a break. And since some people are missing, those of you remote, don't get surprised, having fun. I hope the lesson that you are getting is, visualization is easy. You just need patience and you need a process. All of art is about a process. What is your process? You need to have a process to get somewhere, right? And you will get there. You can create very evocative visualizations that tell stories, clearly explain things. You have to start small. So we only did the simplest of them, the bar chart. And I hope you are, this is very minimal, obviously, very simple, but I hope it gets you started. I'll start with yet another simple one. And by now you may say, well, let's do something more complicated. A day will come for that, but not today. Today we'll do scatter plots now. So scatter plot is, again, follow after me. You have to do it. So let me share my screen and let me know if you can see my screen.
Yeah, we see it.
So once
you
again,
can make it a touch bigger. One control plus would be nice.
Okay, so here we go.
Nice.
So here it is. Once again, I'll run this visualization imports. So now I've just put all the imports in one place. Oh, why am I running it locally? Sorry, excuse me. It's much faster when I run it off the server, but all right, doesn't matter. I'll do it here. Scatter plot, it's locally on the laptop, it takes a long time to run. But okay, guys, don't do this. Keep whatever you had before from your matplotlib visualization, barplot, matplotlib. Just make a copy of it, guys, because the initial code will be exactly the same. The one difference now is we won't deal with the COVID data set. We will deal with the auto data set. So the file name at the end will not be that, it will be auto. So please pay attention that we have this. Maybe Harini, could you please paste it to Slack so people use this? Or Kate,
Yes,
if you
sir.
do that, yeah. So guys, it's a different data set. Now, this data set is, one reason I chose this data set is because many of you have been taking different workshops for this. And we have been using the automobile data set. So it reduces the cognitive load. You don't have to spend time understanding it. Also, it's very easy to understand for those of you who are new. What somebody did in the 1970s is, and it shows it's in the 1970s or 80s, they looked at different models of cars in different countries, in the 3 regions, Japan, Europe, and America. That's why you have these regions, Japan, America, and so forth. I'll let you guess from this which belongs to what. For each car, they looked at how many cylinders it has. So the engine of a car is actually made up of quite literally cylinders with pistons in them. So a cylinder, first of all, how many cylinders it has, Now, what is the size of that cylinder? So suppose you look at it, this as a cylinder, and literally it's like that. In V8 engines, it's a cylinder like this. And you will have a piston that goes back and forth. And so crankshaft, and then there's a crankshaft that converts that piston back and forth into circular motion. So the cylinders are how many of these cans you have, soda cans in a way, you have sitting inside your car. The more they are, the more energy it burns simultaneously, and the more horsepower you get. Generally, more powerful the engine is, right? So for example, many of you are very energy conscious. So you drive, let's say, a 4-cylinder engine, right? The horsepower you'll be getting is somewhere in the order of 150, 160, 180. Is that reasonable? But in those days, the horsepower you would get with a 4-cylinder engine used to be only 90. So we get a lot more horsepower today. But if you go to a 8-cylinder engine, in those days, you used to get a 150 horsepower engine. What is a horsepower? It is the strength of 1 horse. So obviously these days, we can't even imagine how people a couple of centuries used to live. We don't think a bit about cars and horsepowers, but that's what it is. And it depends. So for example, I have an 8-cylinder engine in my car, and I have 600 horsepower. So obviously technology has advanced quite a lot compared to those times. This is the displacement of the engine. The bigger the displacement, in other words, the bigger the size of the soda can into which you're injecting fuel, the bigger, the more powerful will be the sort of the acceleration, right? So weight of the car, obviously, the heavier it is, the slower it, the more fuel it will consume, hopefully, likely. Acceleration is actually the opposite of what you think here. Oh yeah, this is the year, which year it was, so 70s. Now acceleration is how long it takes to reach 60 miles an hour. So the bigger the number, the weaker the car, right? So for example, this car takes, it's a 4-cylinder engine, is rather heavy, doesn't have much horsepower, so it takes 17 seconds to reach 60 miles an hour, right? On the other hand, if you look at this big, what used to be considered a power muscle car in those days, it reaches 60 miles an hour in 12.5 seconds. Of course, by modern standards, you would laugh at it because you would say, well, my car reaches it in 4 seconds or something like that, if you have a Tesla or you have a muscle car. So the world has changed since then, but this is what the data is. Now, if you look at the data, the name column is not doing much. It's useless. So we will drop the name column. Now in this data, there is, so if you look at this data, well, at this moment, the name column, these are statistical descriptions. Let me decrease the font one little bit. Yeah, statistical descriptions. You have the count, 397 data points. For miles per gallon, in those days, 23 miles per gallon was the average among cars. The average number of cylinders in the car used to be 5.4, which means it was leaning more towards 6 cylinders, because these things typically go in even numbers. And why do they go in even numbers? Because engines are shaped like this. So if you put a cylinder here, you'll put a cylinder here also, right? So they go in pairs in the V, especially in the V series, which is now more than 800 years, more than 100-year-old design. Displacement, horsepower, weight, acceleration, you see all of those things. And so something to look at. Now, this data has some missing values. So we clean this out. What I will do is this part and this part, data loading and cleanup part, I'm going to just paste it on the Slack, copy it, just copy it into your notebook, because the rest of it you'll actually have to do. This is one cell. To describe the data is another cell. Sorry. To now remove the missing values and all of the clutter in the data and convert it to the right type. Just think of it as data cleanup, and don't pay too much attention to it because we have to focus on visualization.
Data is available on the library.
Yes.
Data.
Just look at the first line. Look at this line. It is all available. Here's
No,
the.
no, no. Is it available on the CSV file available somewhere?
Yes, yes. Look at this URL.
Okay. Okay, I will get it. Okay, thanks.
You see that, right?
Yeah, I saw that.
The support vectors website. It's directly there.
Okay.
Is giving you an error?
Yeah, I think log.
No, let me run this.
It works fine. You don't import the libraries actually. I think that's.
Oh, yes, yes. You haven't imported. Import all the necessary libraries. That just take it from the previous notebook. All those libraries.
Could you go to the data cleanup cell, please?
Yeah, yeah. And I pasted the data cleanup. This one. I
Yeah,
pasted
but that one is giving error. Like when you copy paste it. I don't know why.
No, not me. Maybe something in pasting it in Slack.
It works for me. I copied from Slack. It works for me actually.
It works for you, huh? Yeah. Okay. Let me paste it again and try my luck.
Sometimes the line number in Slack also shows.
So
Okay.
I'll paste it.
Oh, I don't know. Yeah. Yeah. Let's paste it in a way that they get it right. See, Python is very indentation specific. So if you leave some spaces, blank spaces here or there, it gets into trouble. Who are the people who are having trouble?
I am.
Avanti, you are. And okay. Would you like to just read it here and type it?
I'm doing that right now. Yes. I think Harini pasted. No, she's pasting from beginning. Let me try.
Oh. Oh, okay. Don't do that. Actually, copy the imports. No? Just do support vector style and do the imports the way I did it in the other place. Oh, sorry. What is it? Which support vector style? And then copy the imports from the other one, which was, let's go to the top. Now, support vectors common. Let me go. No. The ones that, yeah, all of these. Huh? So let me just copy this over to, yeah. I will just put it here. Guys, do the top like this. Just as you did for the matplotlib bar chart, exactly the same. It will be better. Should I paste it all on this Slack?
No, that one worked, but just the data cleanup thing, it keeps giving me error that string array requires a sequence of strings or pandas.na.
Would you like to share your screen? I can help you right now.
Okay, I'll do that. How do I? It is asking me if this will stop your screen sharing.
That is fine.
I think it's showing my.
Yes, I'm looking at this screen now. Go up a little bit. What's the code? Data.
Data.haspower.
Not equal to null. And what is the as type?
Yeah, and the error it's giving is string array.
Requires a sequence of string or pandas.na. So it's a spacing error. Let's do one thing. It's a hidden error. Do you see the backslash at the end of the sentence?
This one?
Yeah, remove it. Keep removing it and hit delete. Bring the dot drop to the previous slide.
Dot drop to,
yeah. You have to close the function, as type function, yeah. And now bring the dot drop to the previous line. And do the same thing to the previous, as type to this previous one. Most likely it's a hidden space issue somewhere. Try running.
Okay.
You still have, oh no, you can run it only once. If it is gone, then it is gone. Drop column name. Just do data.describe.
Yeah, that's
Just rerun it, the previous cell. Copy paste it and rerun it.
Oh yeah, copy paste. I'll copy paste it.
Your name thing is still there. Very strange. I can't think of what is. All right, let's take it. So in your case, Avanti, just follow through with this. Huh?
Okay.
I don't know what. It's not very obvious what's missing. Everything looks right.
Yeah.
Data, this is right. This is right. Everything looks right.
Yeah. I don't know.
All right, we will deal with it. Did you update your library?
Yes, I did. That's the first thing I did in the morning.
Okay. All right, just hang in there. We'll help with it.
Okay. All right. Thank you.
So let's do scatter plots with them. So to do scatter plots, again, it's very simple. Do you see we are using pandas directly to do that? One liner will produce you a scatter plot. So let's type this line, guys. Data.plot.scatter.
We don't see your screen.
Oh, sorry, I apologize. Are we together? Can we see it now?
Yeah.
Guys, one of you have to mute yourself. I can hear television in the background.
That's me.
So, by the way, Avanti, you might be able to make progress with this plot, even though you can ignore the previous one. This line would still work on your case. Try it out.
Yeah, I'm working. Thank you.
Are we all there, guys? So when you look at this plot, again, the same sort of a thing. There is a bit of clutter here. The plot is workable, but it's very basic. 20 years ago, this would have been very impressive. 25 years ago, today, it doesn't look so impressive, right? So we are going to systematically improve this. We'll apply a dash of style to it. Again, we'll apply ggplot, we'll resize it, pick a color for the points. Let's see what all things we'll do. Resizing of the figure, we are used to doing that, isn't it? Applying the ggplot theme, again, we know how to do it. Pick a color for the points, that will make it look better. Add a bit of transparency to the points, again, will make it look better. Pick the size of the points, how big the points are in the scatter plot. We'll do that. Add a title, slightly change the X and Y label, we can do that. And improve the text formatting with LaTeX. Now, we have done all of this for bar plot. So I'm not going to show step by step, but we'll do it in one fell swoop. And finally, we'll have a tight layout. So see, this in this much code that you're used to, this part, I expect, I don't want to give it to you. I want you to type it in because you can borrow from your other notebooks. This part, you can borrow from your other notebooks. You remember this? Likewise, all of this part you can borrow from your other notebooks. 15.5 this. Let's do that, guys. This part at least, okay, or maybe because you have to borrow, I'll just paste it here. This part, I'll paste it. Oh, you already did. Thank you, Heidi. Then the meat of the matter is here. Let's think through how you create a scatter plot. Very easy, data plot scatter. You have to give the X and Y axis. Let's look at the scatter plot. You have to give the X axis and the Y axis. We did that, X axis, Y axis. Now S is for size. Size of what? Size of this bubbles, these circles or these dots, points. So 150 is the size that you're looking at. If you make it smaller than this, let's say, what would happen if you make it only, let's say, 10? I'll just make it smaller and show what happens. It will come through in a minute. Yeah. So guys, what do you notice? What happened to the dots? They're too small, right? And does it look aesthetically pleasing? It doesn't look as pleasing as if you go and make the dots a little bit bigger. I've done that. Color salmon, by now you must have realized that I tend to like warm reddish colors. So this is salmon color. Edge color. This is interesting. Whenever you make bubbles, I find that it's aesthetically pleasing to put a little edge to the bubbles, the edge color. When you make it K is black. It will make it some shade of black or gray, right? And alpha, do we remember what alpha stands for, guys? Transparency. Just make it a little bit muted so it looks pretty. So this is it. So far, so good. It looks simple. For LaTeX title, you notice that I'm using the LaTeX language. Title is this, and I'm explicitly giving the style. So this part, because it is LaTeX, I will give it again to you, but please type the scatter plot part, the scatter part. And then the tight layout by now, you should be pretty familiar with. And this is going to be a fun journey, guys. We are going to some very interesting place. And this part, I'll let you, have you guys typed this part in? I want you to hand type it so you develop some muscle memory about it. Are we all there? Sachin, are you done? Yeah, Abhishek, you guys are all done here. Huh? Nice.
You have all this in LaTeX, but what if I don't want to use LaTeX? What will be the plt.type?
Oh, then don't use LaTeX. For example, if you don't want to use LaTeX, don't use it. I'll just comment this out and show you without LaTeX. The same thing, plt.title, right? Automobile. Actually, let me use double quote here because it has automobiles mileage versus horsepower. Again, size is equal to 24. You don't have to use LaTeX. You notice that I'm not using LaTeX. See the difference? It is a plain simple string. I'll run it.
Thank you.
It looks like this.
Thank you.
If you look very closely, you will realize that it is not as crisp or clear as when you use LaTeX, right? So people who are sensitive, depends on that. See, I come from a tradition where when you write papers, you're supposed to write it to a good aesthetic standard. You're supposed to care about the formatting. So yeah, you see the difference between the two? LaTeX versus non-LaTeX?
Yeah.
That's it. But if you don't want to use LaTeX, that's perfectly fine. So now guys, we have reached this thing. I hope you find that this looks significantly better as a scatter plot. What do you see in the scatter plot? Unfortunately, the more powerful machine you use, horsepower you use, the smaller the mileage, isn't it? I was always hoping for a parallel universe in which the more powerful a machine is, the more the mileage, but that doesn't seem to be. All right, so we'll move forward with that. Now, you notice that I have the things here, 50, 75, 100. I will just play around with it, the X ticks. Can I put the, those ticks at the top? You can. It is called a secondary axis. If you want, you can create a secondary axis. How do you do that? All of this code is exactly the same. Then we will do something funny. Figure, auto layout, true, this, that. All of these are properties that you can play with. What you do is a secondary axis. You say that I want something at the top as a secondary axis, and to the secondary axis, you give it a label, horsepower and so forth. Do you see this, guys? It is a way of putting something at the top. So please copy and do this. And by the way, if you don't want to write LaTeX in R double quotes, don't write LaTeX. Remove R and just put a normal string there. So that's the only thing you're adding to your plot. Then one more thing you should do. See, so anyway, do that and run it, and you should see that the label should have gone to the top. I mean, this X ticks should have gone to the top. Right now, here is something more we did. You say that, this plot is fine, but what if the color depended upon the weight of the car? The bigger the weight, it should be a different color, right? See, if you look at the data set, we have taken only 2 columns, horsepower and mileage. And this question keeps coming up. I believe, Abhishek, or somebody asked this question. How do you show more dimensions of the data? So the most easy way is you say, okay, I'll make a 3-dimensional plot. But 3-dimensional plots are actually very hard to understand. So the visualization people, they believe that it is better to be in 2 dimensions as much as possible. So here, what are the things we can play with? We can play with the color of the bubble, and we can play with the size of the bubble, isn't it, guys? Right? So let's use the color and the size to do something. What we do is we use the color. At this moment, we are not playing with the size of the bubble. We are just saying color comes through weight. But the moment you pick a weight, now the thing is what color map you use to color it, isn't it? And I told you that there are many standard color maps. We used jet a little while ago. This time we'll use rainbow and see how it is. That's the only change. So add these 2 also to your scatter. Are we all done? So the extra thing we did is we added a secondary axis at the top, x-axis, and we did this color. We colored it by weight. And by the way, you can play around, like for example, when you do that, you get a plot like this, the rainbow-like color, right? At the bottom is violet, at the top is obviously red. What is it called? Violet, VIBGYOR, violet, indigo, green, etc., right? You get that.
So that gets generated automatically.
Yeah, color map. Yeah, once you specify the CMAP, that is the CMAP argument in Matplotlib and C1. Just give a name of the color map, and because weight is a continuous variable, it will pick it up from the spectrum.
And so it will do the index between those 2,
Yeah,
and then
it will automatically do that. It's very nice actually, right? So what if I made it, instead of rainbow, I made it viridis? Let's see. Another color map. It will take a little bit. Actually, it's running off my laptop. It will take a little bit. Oh, here we go. Do you notice that it's not as vibrant anymore, right? It is mostly the verdant colors. Then suppose I made it jet, another known color map. Do you notice that it is blue to red, right? Spectrum is blue to red, deep red, right? So there are many ones. You can play with plasma, and plasma will look like this. So there are a lot of color jets. In this particular case, I felt that rainbow was or jet. Let's try jet. Did I try jet? I don't know if I tried jet. Okay, here it is, jet. Right. So this is it. You can play with color maps. But so what does the color signify? It signifies the weight of the car. But then we still can play with the size of the dots, right? Or maybe we can give to size of the dots, we can give what, horsepower or something. Horsepower is already there. Mileage is there. Weight is there. What can we give? Maybe we can give, let's see what I gave here. Okay, colors, alpha, automobile mileage versus horsepower. Okay, this is by origin. Suppose you say that the color is by origin of the automobile. I put all the automobiles of Europe separately, Japan separately in that. The code gets a little complex, guys. Huh? You have to know in pandas, there is a way to group the data. So you have to group the data by origin. You see that I've grouped the data by origin. And then how many origins are here? Here are 3 origins. You have to take the color map, let's say rainbow, and split it into 3 separate colors. This part, right, will be tough. So let me give you guys this part. Oh, you already put it? Groups, yes, thank you. So you take this part. After that, the rest of it is exactly what you had. But now you will have to use not the plot, you'll have to create the inner axis object, the graphical object. You'll have to delve into that. You have to muck around a little bit here, unfortunately. And you have to make the plot. So here's the thing, guys. You have to first make the same scatter plot for European cars, give it one color. You have to make it for Japanese cars, give it one color. You have to map it for American cars and map it to one color. And so because you're continuously painting on the same landscape or the same canvas, what will happen is that it will look like this. It will look as though it's a single graph, but actually is 3 plots layered on top of each other. Are we together? Right. So grouping on categoricals is a little bit tricky because you have to do this group and this bit of code. This part may be a little hard. I study it quietly later. I will just explain it for now. See, when you do plots, not subplots. So this is a good day. I was going to explain the anatomy of a matplotlib plot in detail, but think of it like that. See, if you think of the, let's look at this. Guys, you see this book, right? The book has a container, the cover, and then there are pages inside, isn't it? Now the pages have, I don't know, figures and text and chapters and table of content and many things. This is a close analogy of how Matplotlib thinks. This entire thing is a plot or a figure, is a figure. A figure is a container which contains pages. Pages contain paragraphs, chapters, etc. All of those things that a figure contains is called axis, right? And axis, the word axis is poor choice of words. I would just call it thing. It contains things, and things sometimes contains things inside them, right? So at the outermost level, the figure contains the plot, the actual thing that you see. That is one axis, the bigger out, the big container. And that is what is represented with the word AX, right? When you create plot.subplots, it doesn't give you, it gives you only one subplot. In other words, the main plot, the actual thing itself. Inside it, think of it that you get the bundle of pages. Are we together? Right. So figure is the outer shell, and this is the main thing. Another way a lot of people think is that, you know, figure is just the wrapper. This axis is the real plot. Often people use the language like that. It is the real plot or the graphic thing, right? So then what you do is you have three groups. You have groups, three groups. You enumerate over the groups, right? And at each stage, what do? You do a scatter plot. Let's look at it. This plot should look very obvious. Data is that group. American cars, Japanese cars, and so forth, European cars and so forth, each of the group. X is horsepower, Y is miles per gallon. This is obvious, right? We have been doing that. Size of the dot is 150, which is exactly what we have done. Edge color, alpha is very easy. Label, we label that particular scatter plot dots because, you know, we want to put some legend saying which origin it is. Label here is the origin, right? Label is name of the group, right? And colors, where do we get the colors from? We are getting the colors from the color map. You know, we broke out the color map into 3 colors. Well, we know that the length of origins is 3. I could have hardwired 3, but that's hardwiring a value. Here I'm letting the data computed. So this is a little bit of a Python stuff for computing how many unique values are there for origin. It will be 3. So this array has 3 elements, and therefore there'll be 3 things showing up. 1 for each of the origin. This is it. So do we understand this this plot, this thing, guys? And this is just the outer loop to go over each of the groups of cars.
So the reason you're doing this is because the scatter plot only takes one color at a time. Is that the reason?
Yeah, it's one of the limitations. This is the way you do it. So, you know, all of these libraries, they will do most things very well, and suddenly you'll come to something which is very simple actually, but you have to run around in loops to do it. So, well, it is what it is. So excellent way to make contribution to open source. Just go fix this. The rest of it is just title, etc. So this part, Harini, you gave this entire part, right? Yeah, thank you. So guys, just look at this, play around with this. I would have liked that this part, at least you hand typed. Rest of it, you copy pasted. This part, the for loop and the fig from here, you hand type if you can. That will be beneficial. Now you get this plot. You say, oh, that's a lot of hard work just to produce a scatter plot. And you will see that this weakness is not there in other plotting libraries. When we use the other ones, it won't have this problem. Now we go to the cylinders. Suppose we say, okay, everything is fine, but I can still play with the bubble size. Let's use one more feature for bubble size. Suppose you pick the bubble size based on the number of cylinders, right? So we all talk about V4, V6, V8, V12, right? So suppose that looks very attractive if you know cars. So you may want to do that. The trouble is, Matplotlib, if you give it numbers like 2, 4, 6, 8, they will all look practically the same because it's a linear scale. So you have to amplify it. One way that I amplified it is I made it 2 to the power horsepower, right? So it'll 2 cylinders means 4, 4 cylinders means 16. You got the idea, right? 8 cylinders means 32, and so on and so forth. Use a more exponential scale, which is what you see me doing. I created a new column called size, which is, oh no, actually I didn't do that. I squared it. So this is wrong, this documentation. It's not 2 to the power. I wanted to do that, but I actually did power 2, square of it. Well, square is good enough. You square it. You can play with this. You can make it 2 to the power this, that. Okay. So, and then I multiplied by 10 just to get a good size. So these are the things, statements like this, where you find yourself playing with the data to make the graphics look good, right? It isn't something like, it's not a rule book. you play with it. It's part of the experimentation process to make a visualization look good. But once you do that, the rest of the code is exactly the same, except that S is now equal to the size. Remember, we just created a size column. And so S is equal to size. When you do that, are we guys seeing this? S is equal to size. When you do that, now you notice that your bubbles have become big. Observe something. Most of these big bubbles, they belong to which origin? One, right? Isn't it? One happens to be America, by the way, US. So it turns out that the biggest market for big cars, high horsepower muscle cars, has been traditionally the US. Right? It has to be. I mean, US has always had a love affair with cars, and it shows through in this data. Right? It clearly shows through in the data. Two happens to be Japan. Well, Japanese prefer things small most of the time, and you can see a preponderance of green color. Japan cars being small, they also have their muscle cars, a few, but mostly they are small cars. Right? Sizes of their bubbles are small. We are learning something about data. Do you see how much you can make your visualization tell about the data? Just in one stroke, you can tell that big cars tend to be prevalent in the US, right? In the US region. So now one thing you want to do, sometimes you want to point out to specific data points. You want to do annotations. So this part, guys, please do it yourself. Harini, you have given the code up to here, right? Up to here, you have given the code?
No, sir, I haven't started the annotations one.
No, don't give the annotation.
Yeah, no, I haven't.
Yeah, but till here you have given, right?
Yes, yes.
So annotation is, what is annotation? Do you notice that these are some comments you put? Just as you annotate on the book in the margins, in a plot, sometimes you want to annotate and put some comments there in the plot, right? So how do you annotate? This is we will learn to annotate it. So what we are doing is we are putting the min max of horsepower and min max of mileage, right? To do that, we use this. So guys, at least type one of them. You may not type all of them, but I want you to type one of them. Can you please add this to your plots? Then I'll explain it. By the way, annotations you could have done for line plots, any plots, bar plots, anywhere. And by the way, oh, sorry, I must say, you can't annotate till you find those values, right? So here is the min value, max value. You must compute it first. So let me give you the code to compute it first. And you must have computed the min max of each of these before you go ahead and start annotating it, right? And this is the text. This is the Python way of writing the text. The text that you will put in the annotation is here. So just copy this much, guys, and copy this much. Are you all done, guys?
Still typing.
Okay, take your time. I'll wait a few minutes. It's worth knowing how to annotate plots, guys. Huh? Very few people realize that you can actually annotate plots to highlight the message or the story you're trying to tell, or the main point you're trying to explain. You can put it in the graph itself.
I got it working. It's working.
Got it working. Very good. Anybody else? Avanti, were you able to come this far, or it's you got blocked?
I am having issues, but I'm doing all the typing, copying everything. I'll run it later.
Okay, sure. Nice. So let me explain this code. We'll just focus on this minimum miles per gallon. Let's look at the plot. Where is the point with the minimum miles per gallon? I might have the automobile with the minimum horsepower. Okay, let me take this. The automobile with the minimum miles per gallon. Would you agree that this is this point? Lowest MPG.
Yep.
Yes.
Big heavy vehicle running in the US, right? So it has the minimum. So it has a coordinates. Its coordinates would be minimum MPG and whatever the horsepower value is. Then we have an arrow. And then we have a location where we have put the text. Right? So we need three things: the XY coordinates of the data point, we need the text and a location for the text, and we need therefore an arrow to connect the two. Right? These three things. So let's go to that. First of all, we figured out the horsepower, the minimum, the XY coordinates. X-axis is horsepower, Y-axis is MPG. Here, we did it for the minimum. So how do we calculate it? That's a little bit of computation. This is standard Python. So in the data frame, you find out, and pandas doesn't make it very obvious. And unfortunately, this is the best that I could do. And quickly, the shortest code I could think of to find the XY coordinates of the mileage minimum. This is standard Python. Once I did that, min max, min mileage, min horsepower, and so forth, then what I do is I come to this. This is the F notation, the formatting notation. The automobile with the minimum, and this is it, minimum mileage. This is standard Python string syntax, formatted string syntax. If you're used to the percentage syntax, then you might want to switch over to that. This is the new way of doing it in Python. Now let's look at that. Remember three things: XY coordinates of the point, location of the text, and the arrow kind. So let's do that. XY of the point is this, right? Location of the text is relative to the point that you're talking about. So I'm saying minus 200, 200. What does that mean? X-axis. So you see that this is here, right? And you go 200 pixels to this side, which is, this is in pixel format. So you go 200 pixels, you go this far. And 200 pixels up, 200 units up, you go here. Right? Why is it like this? I don't know. it should have been. All right. So this typically you play with and see what it means. Huh? So in my case, I am trying to understand why. But anyway, you need to give the location of the text relative to the point. Once you have done that, location of the point with the relative to this, then what is the next thing you need to specify? What is the kind of coordinates it is? So offset point means relative to the point itself. And then finally, you need to draw the arrow. Here it is. Arrow has the properties. Do you notice that it's a maroon in color and rather thick? Line is thick. Line width is 4 and it is maroon in color. So this is there in the documentation for the annotation, but I'm explaining it here. This is how you do it. Maroon colored, really thick, fat line arrow. And finally, the text. What is the font size of the text? 16 points. Right. So 16 point here. And likewise, the other annotation. So does this now make sense, guys? Do all this make sense? This is the text place for the point here. No, location of the text should be here relative to use the offset points coordinates. And then this is the arrow property and the text font size. These are just properties of the annotation, right? Annotation is that arrow and text put together. Is it making sense, guys? So this is it. And so do that. And now you notice that to the extent that a purpose of a visualization is to explain and tell a story, is it able to tell a story? It's talking about all the extremes in this plot, right? So you now look at it and you can literally read off without having to guess that the maximum mileage you get is 46.6 for what is the size? The size is the weight, I believe. Tiny size, or no, horsepower. Cylinders. Size is cylinders, isn't it, guys? What did I put size as? Size is cylinders, yeah. So it has fewer cylinders, a high mileage vehicle, right? Its horsepower is low. You would expect fuel efficient cars don't have a high pickup. So we did that. Now, one more topic worth thinking is sometimes what you want to do, and this one, I won't make you type. I'll just explain it to you and you can do it on your own. Let's look at what we are saying. So suppose you have a graph and you want to pay attention to certain regions like this region, green region, yellow region, or any 2-3 regions you want to zoom into. How would you zoom into and show it? What you can do is you can draw the plot, but you can highlight those regions. And then you can make separate subplots for each of those regions. Are we together? Now, to do that is actually not complicated. I'll show you how to do that. But the code becomes longer, which is why I want to ask you to do. So let's start reading the code from the top. From here to here, I hope it is easy. Everything is familiar. Isn't it? No surprises. We have done this before, right? We get the figure, and then what you do is you start creating subplots. Let me explain subplots to you. Look at the anatomy of the plot. There is one big plot at the top and 3 at the bottom. So now how do you right? So far, so good, right? If you think of it as a grid, those of you are familiar with HTML plotting, right? If you think of it as a table with 2 rows and 3 columns, then the figure at the top, the subplot at the top, has occupied the entire first row. So how many columns has it occupied? 3 columns. right? And this is the 4th, 5th, 6th figure subplot, each occupying only one column.
So, Asif, my connection went down a little bit. Can you please repeat the last 1
Yeah,
minute?
I'm saying that whenever you see a visualization like this, let me decrease the font. When you see a visualization like this, you notice an asymmetry. The top is one big row. One entire row is one plot, right? Or one subplot. The bottom is 3 subplots. How do you
Okay.
think of it in a grid framework? One way to do that is you think of it as 2 rows and 3 columns, right? Except that the figure in the first row has gone and occupied all 3 columns,
Yeah.
right? Whereas bottom row columns are subplots are just normal subplots. So we are going to play that game here. We say that the main plot is, it is a sub, so basically you have 2 rows, right? In the first column, you put the first object. Actually, it should be 2, 3, not 2, 1, but okay, this was a mistake. 2, 3, 1, you plot it like this. 2, 3 means 2 rows, 3 columns, but the first figure there is this. It will be the main figure at the top. But then for the second one, you say that I'll put it in the 4th location. Then what happens to the second and the third location in the first row? It will automatically get occupied by the first figure. It will stretch out and fill up the space. Are we together, guys? Right. And so 4th, 5th, 6th in the second row, 4th, 5th, 6th slots. They are normal subplots. So now I've created 4 empty slots. So do a favor. Just take this bit of code. Don't do anything else. Right. Let's do this. Let's create a, I'll go to the very bottom somewhere and just experiment with this. To see what happens. Figure. What do you notice, guys? Because I haven't put anything here, you have 1 box here and 3 boxes here, isn't it? You see the layout?
So the first line which says main, that adds up 2, 3, 1.
Yeah. And now what I do is in the first one, the main, so this is main, right? This is main, left, center, right. Main, left, center, right. And now observe what happens if I change this 3 to 1. Yeah, it will basically say that pretend as though the first one is occupying only 1 column. So do you see the game changed? What happened? You're saying 2 rows, 1 column. While you're drawing this, pretend that there's only 1 column. Right. So the first object will go occupy all 3 columns, all 3 locations.
What is the first 2?
The number of rows and the number of columns.
But main only have 1.
No, that is why it has 2 rows. Remember, first is 2 rows. It is saying that okay, let me put it this way. Let me write it down as for you. No, I'll draw it out for you. Give me a second. Yeah, this is very confusing actually. Grid spec is the hardest thing for people to understand, so I should explain it. 1 second. I'm trying to bring up the writing pad. OneNote. All right, let's add a page here. Now, see what I'm going to do. The syntax. First, let's think of the syntax, right? What you do is you claim that you have created a subplot, right? And you say, imagine that there are two rows. Okay, let me first give the syntax. Number of rows, number of columns. So the moment you specify this, in basically a grid is formed, right? So suppose it is equal to, let me just say 3. And let's say that this is equal to 5. The moment you do this, and we haven't specified this, what has happened? The graphic engine has immediately started creating 3 rows, first row, second row, third row, isn't it?
These many subplots. 15.
Yes, sub 15. It will end up creating 15 subplot. This is the first column, second column, third column, right? And then it says, okay, now that this subplot is here, this particular one, this axis, where do you want to put it? So suppose I say 7th location or index. Now let's count 7. 1, 2, 3, 4, 5, 6, 7. Oh, it will get plotted here, right? That is how you think of the syntax, right? Suppose I did instead end row 3, 5, and I did 2. Where would it go? It would go here. If on the other hand, I did, let's say 12, where would it go? 8, 9, 10, 11, 12. It would go here. Are you understanding it? So this specifies the nature of the grid. And this specifies the index or location in the grid. So if you want to now let's see how we will pretend and play this game. Suppose I want to do this. I want to make this, right? So I need to fool the system a little bit. First, what I will pretend is, suppose I did this, 2, 3, 2, 3. And then suppose I say 2, 3. What is this? What is this location? 1, 1, 2, 3, 4, 5. I would have to say 5, isn't it? So this is the center is equal to 5. What about this? Left is equal to 4 and right is equal to 6. Now this is 1, 2, 3. But now I want to fool the system while drawing this, right? I want to take up this whole space. So what I will do is when I'm doing this main one, I can pretend, I can confuse. So let's first do this. I will just limit it to this. First, let's do 2, 3. Okay. No, not yet. Actually, so here's the thing. Suppose I gave it in this figure a 2, 3, 1. Main, I made it 2, 3, 1. What would happen here? These things never got occupied, never got created, isn't it? We never created a subplot in this place, number 2 and number 3 place. We created 1, 4, 5, 6. Does this make sense? But we want to not cheat it. We want this first figure to occupy the whole space. So what happens is when we are drawing the main, we cheat. We say that, hey, you know what? Actually, it is 2 rows, but only 1 column, right? And if we tell it it's only 1 column and you are in the first location, now what happens? This will go and occupy the whole thing. You got the rationale behind it, right? So that is what is being said. Yeah. And this is the part that is actually grid spec is the part that most people actually, I also should fix this back. No, this is the part that is most confusing, the subplot location, right? So you have to remember the first is number of rows, number of columns, and then what is the index there in that grid? Are we together? So that with that knowledge here, now let us look at this. So where did I keep my pen? Writing pen is, okay, I'll find it in a moment. All right. So, so this is that, laying out the main pieces. These are empty plots, right? At this moment, these plots are empty. Once again, we want to group by origin. So the same old code of grouping by origin, putting the cylinders and everything else is there. So the main plot is easy, right? Main plot is the same old code. Nothing has changed for the main. Do you all agree that the main plot is the same as the same code that we wrote a little while ago? Right? The top plot, this plot is the same. But then we need to draw the three regions. Do you notice that I've highlighted the, we'll do that in a little bit. We'll color fill it. We need to now go and make the three lower boxes. We need to make this, this, and this. But when we do that, we take subregions. We are zooming in. So how do we zoom in? The same thing. We do that, except that we take the data, MPG size, etc. But we limit it to this specific part. So data is part one. Where do we get the parts? We actually, this is a part you have to do. We create three subsets of data. See, when you zoom in, what it means, you're looking at subsets of data, isn't it, guys? When you zoom into data, you're looking at only a subset of data, some part of the data. So by deliberately, I took three parts: low horsepower machines, regular horsepower machines, and high horsepower machines. From those times, today, these things would hardly be considered high horsepower. So I divided the data set into three regions of interest. I'm not looking at all other regions, three regions of interest. Why three? Just randomly. I just wanted to show how you would zoom in. So what happens in the lower plot? So think about it. This plot is over the entire data, but these lower plots, all they have to be is regular scatter plots, but on individual zoomed in pieces of data, isn't it? Does that make sense, guys? All I have to do is make it over zoomed in pieces of data. And so that is all it is. Nothing but the same scatter plot as the main, except that I pass it part one, part two, part three, right? Zoomed in pieces of data, because then you can see what is happening right here in much more clear form here. What is happening here, I can see in a clear form here in this. So this is how you would zoom into three different regions of the data. Now, just to show what parts we are zooming in, this is color the three regions, you know, you color between. So there is this lovely method called fill between. You can give it the range where you want the data to be colored, and it will go color it for you. Right. So this is a way that you would zoom into data. Now, this is a complex graph, guys. Huh? Are you feeling, I hope you're realizing that even though it's a lot of code, it is actually very straightforward code repeated. You make the main plot and then you make the subplots just in smaller sets of data. Anybody wants me to explain it again?
Yeah, I can go one more time on the part 2, 1, 2, and 3, please.
Oh, you mean the grid part? Huh? How do I do that?
Yeah, the grid one, yeah.
Okay, let me say that again. Where is the OneNote? And where is the pencil that I dropped? I hope I didn't drop my pen to write with. I must have. Okay, I'll take the other pen then. Okay. Give me a moment. See, Matplotlib thinks in terms of grids. You divide the main plot into a grid, rectangular grid. You always think of grid. When you think of a grid, the thing that matters is number of rows and number of columns, isn't it? So suppose number of rows is, in this particular case, 2, and number of columns is 3. So when you say, now this is it. Now what you do is you assume that this grid is there. Suppose you want to draw it out.
Number of rows are 3.
Oh, I'm sorry. Number of rows is also 3. Well, something should be different. So I'll make the number of columns 4. Right? Now you ask yourself, suppose this is the grid, where do you want to place a figure? Right? Let us say that you want to place a figure here. Right? Let's call
Okay.
this figure A.
Yeah.
Right? A. So A is what location? You have to index it. 1, 2, 3, 4, 5, 6, 7, 8. So you will say A is equal to fig dot subplot subplots. By the way, I may be screwing up the exact thing here, but we'll come to that. 3 rows in a grid of 3 by 4, the location 8. So the way to interpret it is in a grid of 3 rows and 4 columns, this subplot must be put in location index 8. This is literally like, if you have to spell it out what this word means, it means this sentence.
Yep.
You got that, right?
Yep.
And now, suppose you want to do, now let's play a game. Now you can go and you can say B is equal to, so now B, how would you write? It will be, what will be the index here? 3, 4, and what would be the index here?
10.
10, exactly. This is how you play this game. Now, sometimes what you want to do is you want to mess with it a little bit. So suppose you want to put a figure, you want to fit a figure that occupies, let's say, all of this location, right? So this location would be 9, 10, 11, 12, right?
Okay.
How would you do that? Right? So now you have to play a game, right? You have to confuse this system. So you would start saying, hey, you know what? It is actually 3 rows, right? Yeah. So 1 column, right? 3 rows, 1 column. And I want to put it in the, if it is 3 rows, 1 column, right? Then I have to be in the first place or second, whatever, third row. So 1, 2, 3, right? If it is just 1 column, 1, 2, 3, right? In this is it. But then what will happen is this system will get fooled. It will say, oh, really? Okay. So here, imagine that I have a grid which is 3, 1, 3, 1, and I'm in the 3rd location. You see how it goes, right? Right. So this is it. You have to play with it. And then there is such a thing called grid spec, which gives you even more power, right? So by now you realize that data visualization, right? You have to play with the geometric primitives. And sometimes you have to master the tricks that help you sort of work with what you got, right? If the API doesn't give you, so for example, in CSS, in HTML, some of you would remember a thing called call span, right? So you could have literally said call span 3 or call span 4, like go take all the 4 columns. But in Matplotlib, you don't have that. The best you can do is play games like this, right? That is all we are saying.
That is quite used in the responsive design, right? Like when you change the screen size and things like that.
Yes.
Yeah.
You can please show the code for the splitting of the data for a specific grid.
Yes, I will show that to you now. So guys, are you having fun? But we need to move a little faster here, but make sure that we understand it. So where am I? You take the data and you split it into 3 parts. Do you see the splitting? I just happen to take 3 regions to zoom into. Literally create 3 different data frames, which are subsets of the data, isn't it?
Okay.
And so it is easy. In the main top, I go and put now in the tame, do you notice that I pretend everywhere I say it's a 2x3 grid, but for main, because I wanted to occupy the entire row, I confuse the system by saying 2x1.
2, 1, 1.
Right? That's that. And so that is it. The rest of the code is exactly the group by code data, except that you do the entire data. But for subplots zoomed in, do you notice what are you giving in the enumerate? You're giving the part.
Okay.
Right? The subsets of the data. That is all it is. So the point is that you need to be able to break a vision. So when you look at this visualization, your first reaction may be, now how in the world am I going to draw this? Right? And the trick of it is that you break it up into pieces and you think along different pieces, right? Different data sets and so forth. And you zoom in there. So that is zooming.
Yes.
You can do it with grid spec for finer control. Oh, I haven't filled this section. Interesting. Okay, so there is, if you want even more control on where to put what and so forth, there is in Matplotlib something called the grid spec. You can use the grid spec to place it all over the place, right? You can get really fancy. But I won't do that. But you look at scatter plot, let's go to the next dimension. So this code, right? I hope you understand it now. It will take you time to absorb. I would suggest spend at least half an hour to 1 hour thinking through this code when you get it, right? And you'll realize that this is nothing but repetition, except for that trick. It's a repetition of this code. This code that we wrote, it is literally repeating this code here, right? Over a few times. So now we'll do 3D plots. So now you say that, all right, this is all very good, that we can use the bubble size and all of that. But what about I want to bring in a 5th dimension, right? I want to show data in 3D plot. How do you make 3D plots? So let's do 3D plots here. Right. First of all, the usual things, color, origin, define a row. So you create a color column and so
Can you
forth.
repeat that thing? Why do you need a 3D plot now? Because you ran out of.
Yeah,
possibilities.
there are only 4 maximum features you can do in 2 dimensions. Now, what about the 5th feature if you have one?
So one was color, then the size.
No, not the color. It was horsepower. Yeah, you use color, size, X and Y,
color,
Location.
size, and-
X and Y coordinates. Okay, guys, I'll take a 2-minute bio break. Give me 2 minutes. A very short bio break and I'll be back. 3D. Right? How do we do 3-dimensional plots? So let's go and do 3-dimensional plots. First of all, we'll just create one more, literally a column called color. So, origin, we are coloring it differently. Might as well add that color as a column to the data set itself. Once we do that, now let's see how do we do 3 dimensions. It's more interesting actually, but easy, very easy. People always get scared. Oh my God, 3-dimensional visualization. How will I do it? It turns out it's very easy. I will just do it. Figure this part, color. Okay. So from here to here, I hope you all agree that we have seen this. There's nothing magical here, right? This is all repetition. You create colors for the 3 origins and this. Actually, why do I even need this? I've already put a color here. Maybe this is redundant. Then what do? You want to create a 3D plot. So all you have to do is, now look at this syntax, 1, 1, 1, right? It is just a short form of saying 1 row, 1 column, first location, which is the same as saying basically there is only 1 figure there. Isn't that, guys? Right? But the way it works is that most of the time, see, I've been doing plot.title, plot.this, plot.that. Now I want to change your habit, not to use PLT, but to use the explicit object, which is the axis, the main plot, the main figure object inside it, which is the axis. Yeah.
Now, can you quickly repeat that the difference between AX, IS, and you were saying?
Axis, AX, ES. So here's the thing. Think of,
Rulers of AX.
yeah. See, look at this jar. Look at this jar of stones, right? A plot is this, the figure. This is the figure.
AX is inside it.
everything that is inside a figure is axis, AX, right? AXES, AXES. Now, why they chose the word AXES, I don't know, but everything, all the stones inside are that. Another thing is, it isn't just the stone, because stones don't contain stones inside them. But in this particular case, think of it more like this book. This is the figure, book is the figure, but inside the book are the pages, right? But the pages contain chapters, chapters contain sentences, paragraphs. So axis can contain axis inside them, axis object. So everything in Matplotlib, whether it is the ticks, ticks, the label, the actual plotting, the line plot, bubbles, or whether it is every spline, everything is an axis, AXES object. And AXES in Matplotlib is not a plural of axis. It is just a peculiar choice of word.
It's an object inside the figure.
Yeah, exactly. Right. So when you do a subplot like this, what you're saying is that you are creating just one, you in the figure, the one thing plot, you're going to actually make only one plot. Right? That's all you're saying. At one row, one column, one plot, right? One location. But the more crucial word is projection is equal to 3D. What it means now is there won't be two axes. Typically, a plot will have two axes, X and Y axis, right? But now you're saying it will have three axes, right? It will be like this. That's all we are saying. So we have created an empty plot, AX, which has three axes, and we can play this game. Let's do that. I will let's do that here. 1 second. Huh? I will do this, and I will say fig dot. We'll go back up and see what did I do here. Plot fig subplot. Okay, add subplot. So I will use this fig dot add subplot. Projection is equal to 3D, right? What has happened? Yeah, you see that there is an 111 is assumed. So in fact, from here also, I can remove it. It was unnecessary. But 3D projection means how many axes are visible now? Yeah, X, Y, Z, three things are visible, right? That is the difference. If you did not do this, for example, if you did not say 3D, then always it implies 2D.
Can you do the 3D and put 2
Oh, yes, yes, we can do all of those games if you want. So, for example, if you do, well, we can do that. Huh? Let's say A is equal to subplot 1, 2, 1, 1, right? So this is it. So do you notice what did it do? It is expecting you to bring more, right? 2 rows, 1 column. First, now it is waiting for you to do, suppose I do this, B is equal to, same thing. Let's do fig 2, 1, 2. What happens? One on top of the other. You see that, right? You understand how it is happening. Right? That is the convention. That is a convention it follows. Right? So now we are going to, so this line now is understood, right? This line we understand, right? Now all we do is scatter plot. You have to give X, Y, and Z. You're saying data.horsepower is X, weight is Y, miles per gallon is Z. But you still have that extra degrees of freedom. Color is coming from the origin. At this moment, we have given size as 100. Let it be a fixed size. Edge color, label is the origin, like whatever color is that. And you do that. Now the difference with 3D is 3D has a problem. A 2D, you look straight on, right? In a page, you're looking at a wall. But in 3D, the special thing that comes is, where are you looking at it from? Because if I give you a 3D object, it may look different from different directions, isn't it? So from which angle are you looking? So you have to specify where are you looking from. It is called the camera location. Where is the camera with respect to this, the X, Y, and so forth? So you're looking at it. And so I've just put some sensible values, you play with it here. So now you get a 3D plot. Do you see that? Right. So you're literally looking up into it. Do you see? Because of the minus, you seem to be looking up a little bit into it, right? And you got your 3D plot. Now this, as you know, observe that this you can't play with, you can't rotate, you can't do anything, right? Now I've given a couple of more examples of 3D. So guys, at this moment, you guys are not repeating after me. We are beginning to run out of time and I have some more territory to cover, but are we understanding it? If anybody wants me to explain anything again, please stop me. Anyone? Now notice one more thing. Do you notice that we are setting the label of X, Y, and Z? Why? Because we literally have 3 coordinate axes, right? So we do that. Now you can visualize more data. This is one famous data called the S-curve. When you do machine learning, you will realize that I will give you these problems that find the embeddings or so forth. This is called manifold learning, especially that it is a surface that is hiding in 3 dimensions, right? It's like a 2-dimensional surface hiding in 3 dimensions. So if you want to visualize, nothing magical here. All you have to do is show it. I just wanted to illustrate how easy it is to make 3D visualization. Note that by definition, it's not interactive unless you make it interactive, right? The well-known S-curve. And then there's the Swiss roll curve. You see the Swiss roll in 3. Again, it's a 2D surface hiding in 3 dimensions, right? So you can do that. Anyway, this is what I was explaining to you, the nature of this. So this is with Matplotlib. Let's try the same thing with Plotly and see how that goes. I'll move a little bit fast. We are getting to the end of the day. Same data set, nothing magical. So by default, Plotly, is it looking impressive? Probably not. It's looking okay. Is a little bit of interactivity. You can mouse overs are there. You can zoom, you can pan, you can do all sorts of this sort of thing. You can zoom in, let's say, where is the zoom in? You can zoom in this, you can reset and so forth. So it's an interactive plot. Once again, you can apply a dash of style. By now, you have seen us do Plotly for bar chart. There is nothing different. You remember the title, if you wanted to make the title fancy, we made it a JSON object, right? Same thing here, nothing fancy. The only difference is p-scatterplot. Let's study this part. What are we saying? Horsepower versus MPG. X-axis is horsepower, y-axis is MPG. Size is size. Now, what did we make size as? Size, we said, it is the square of the cylinders, right? And size, color is the origin. Now, template is Plotly dark. Think of it as themes that Plotly has internally, right? Now, what is the width and height? By the way, how many of you remember what is the golden ratio?
14 by 8.
Sort of, yes, 14 by 8, like 1.6 something. Yeah. Let's do that, golden ratio. Is 1.618, right? So remember it as 1.6. Now let's do something. Calculator. And if you do 1,000 by 600, what do you get? Anyone? 1,000 by 600 is what? 1.67, isn't it? Close to the golden ratio. Would you agree? Right? Which is why I always, you must have noticed that I always tend to pick sizes, unless there's a reason not to. I pick sizes close to the golden ratio, right? In art, we make a big deal about it. We have all these rules. And I think some of you know that I started out my life as a painter, like as in not painting walls of houses, but painting canvases, right? So my teacher taught me at a very early age all of these rules that have stayed with me. So here we go. Then, of course, I come from a poor country. Soon I realized it's better to get into engineering. I got into IIT, etc. So, so look at this, guys. I did that. Color is origin, Plotly dark with opacity. What does opacity do? It is the same as alpha. What Matplotlib calls alpha, here in Plotly, you call it opacity. Opacity means how opaque is it, right? The same thing as alpha. The rest of it is very simple. Title, x-axis, y-axis. So I did the aesthetics. How does this look? Looks awesome, isn't it, guys? Right. And you have interactivity. And did we have to write more lines of code? No. In fact, you had to write less lines of code, if anything. Isn't it? So this is the power of D3 underneath it. You can do it, you can export it to, you can download it as a PNG file. Here it is. Right, here's your PNG file. Right, you can embed it and so. So I won't go into that. Why not able to decrease it? Okay. So the point is, and you notice that the LaTeX formatting is here. It's coming out very clearly. Right, colors. I added a splash of color all over the place. Right, salmon color for the title. So you can see that the title is in salmon color. Also notice that I moved the title to the bottom, right? Our title, I moved it to the bottom. So things like that, guys. So this is it. But the best part is, did you notice that we didn't have to do that group by and that confusing for loop? Remember, in this, let's go back up. To do it by regions, yeah. Do you realize that we had to do this group by, and we had to write a complicated for loop over the group by? Do you see it, guys? In Matplotlib, right?
Yeah.
But here, nothing. We don't have to do anything. We are just saying color it by origin. That's it. And Plotly will take care of it automatically. Much simpler. Much, much, much simpler. Right? So this is it. It looks beautiful. Let's go one step further. This is coloring it by origin. But what if you want to color it by, let us say, the weight of the automobile? Right? So the size is the cylinders, right? Square of the cylinders. What if you want to color by weight? All you have to, nothing, no change. All you have to say color by weight. One line change. Literally, guys, between these two code, Plotly handles these separations very well. Let's run this and see what comes about. And you get this beautiful plot. It's by weight now. So who drives big, heavy vehicles? We. I'll let you think over it for some time and appreciate how simple the code here is. By now, is the code beginning to look very easy, guys?
Yeah.
So familiarity makes it easier. You take a few examples and then it becomes much, much easier gradually. How would you add, excuse me, how do you add Plotly, annotations in Plotly? Very similar. Remember, this code was the same code that we did in Matplotlib. You have to break the data out and find the min-max. Once you have found the min-max, here is the annotation syntax. More or less the same, slightly different, you know, a little bit here, there. But when you, let's run it and see what happens. I added only two but a min not defined. Oh, I have to run the previous segment. Yeah, here we go. So do you see the annotation here? Just out of laziness, I put only 2 annotations because now you all know what annotations are, right? So with this visualization, we sort of stop here. But you would agree that this is a pretty good visualization, isn't it?
That's very nice.
Yeah. And normally, if you saw this visualization before this workshop, probably you would have said, I can't do it, right?
Definitely.
Yeah. And yet it is just these few lines and you are there.
You can't do it.
What's it?
Okay, I still can't do it.
You can, I hope. Oh, you can't do it? Okay, then I'm going to stop here and make you do it. Let's start typing. Yeah. Would you like to all just start typing it?
So we should.
I think more than the typing, the constructs has to sink in.
Yes, exactly. But I hope you are seeing that I'm explaining all the pieces. If anything looks not obvious, ask me, guys. Huh? I will explain. But do you notice that? How do you build it? Did I build this plot in one stroke? No, I did not write the whole code at one go. Right. The best way of thinking of it is like you make one powerful visualization over at least 4 cups of coffee. Morning, evening, 2 days. Just skip, do it slowly. At each time, give it just 10-20 minutes. Don't try to do everything in one go till you become very familiar with it. Then you can do it at one go. But till you become familiar, just give yourself 20-minute slots or 10-minute slots and do one little piece and go away. And then again, come back and do it.
So Asif, you should first start with Spotly before going to Matplotlib, or is that how would you
See,
go about doing?
if you look at the internet, you'll find a lot of discussion about how Matplotlib shouldn't be used, Plotly is there, or Seaborn is there, or Altair is there, and therefore you should use all of them. It doesn't work like that. The way I think about it is, you should know the strength of each library. You should see how far you can push it. And then take it only that far, because beyond that, they all have limitations. With Matplotlib being the oldest library, it actually is very versatile. But its problem is, every inch of it's like, you go to a bicycle race, other people bring bicycle, you bring a huge box of parts and you start assembling a very custom bicycle before the race, right? So what you will end up assembling is very powerful, but you have to sit and do it. You see that, right?
So it's like Java and Node.js.
Sort of like that, right?
This one is easier to.
It's a little easier, right? Likewise, now when we do the scatter plot, the code is almost exactly the same, guys. 3D, XYZ. Do you notice this code? I am making a 3D scatter plot. Let's say, first let's look at the scatter plot. This. Now the beautiful thing is it's interactive. See, I can rotate. I don't know if it is showing up in the Zoom. I am rotating.
Yeah,
I am zooming into it, right? Zooming with my mouse, I'm zooming into it, rotating it. I can go in and see what's happening here in this region of the code, right? I could do that. Let's say I could zoom into just this bit of code. There we go, right? This with a mouse, I can move around, I could do things, rotate it, right? And so that is the fun of good visualization libraries, right? And by the way, 3D, I'm just getting started. But next time, if you do all of these notebooks properly and come well-versed so we can move faster. Today was hard because you're breaking new ground. So even now by evening, things look familiar. Would you agree that the things we did in the morning by now look very easy?
Yeah.
Yes.
Okay. Yeah.
Yeah.
So it takes time to get through it, but do give this week to really reviewing and studying the notebooks I publish on the course portal. Be good at it so that next time when we come, we can move faster. We have some beautiful things to do. We have to do network visualizations. We have to do some more 3Ds. We have to do maps. How do you project data onto maps, right? And so things like that. We will have a lot of fun next time, but it can happen only if this time. Oh, by the way, we missed something important. It's already 6 o'clock, going to be 6, so I will stop. We missed line plots. Line plots are easy, right? We will cover them next time. In fact, I will post the notebooks anyway, so that if you get time, do it on your own, right? So this is the S curve. Remember the same S curve we talked about? This is the S curve. And you feel with this is that 3D is great so long as you can interact with it, so long as you can enter into the data, right? And sit in the center and look how it looks from inside the data, right? Likewise, the Swiss roll, no code change. You notice that there is no code change. And if you look at it, could this code have been easier? You have a data frame for the XYZ, or even go to miles per gallon. Would you agree that this is very simple code? X is horsepower, Y is miles per gallon, Z is weight, and then the rest of it, size by weight, color by weight, and this and that. Very simple, right? So that is that. This is your Swiss roll. And you can rotate the Swiss roll and see how it looks from the side, right? Isn't that fun?
Yes.
Right. So this is that. Now we can try. So this was the Plotly library. Let's try a luck with scatterplot Altair. Oh, by the way, there's more to it. Let's go to Seaborn. Seaborn, remember, is just based on Matplotlib. I will be quick because we're running out of time. Remember, Seaborn is Matplotlib. Most of the time you're writing Matplotlib code, except for 1 or 2 helper functions from Seaborn. So the same data, I will just keep running them. So this is your standard scatter plot using Seaborn, right? Not very impressive. But then you can prettify it. The same rules apply. ggplot. This is nothing but your Matplotlib, except that you're using Seaborn to do the scatter plot. You get this. Now notice that here also, you don't have to do the group by. In Matplotlib, you had to do that group by thing. You don't have to do that. Seaborn, as a convenience, just give it origin, it will understand. And so you will get this lovely plot. Color points by weight, if you want to do it by weight, it is again the same code, nothing very fancy, guys. Huh? The hue, the color is by the way, they don't use the word color, they use the word hue, which is a synonym of color. So hue is weight. How do you add annotations? Nothing. It is exactly the Matplotlib code because it's sitting on top of Matplotlib. To that. How do you do zoom boxes? Now, can I leave it as an exercise for you guys? The zoom boxes, right?
Yeah.
3D scatterplot, because it's based on Matplotlib, it doesn't give you anything extra. Actually, this is where it runs out of gas. I mean, it says they haven't put anything extra for 3D plots over Matplotlib. So it's just Matplotlib. But Seaborn gives you something unique of its own. It's called joint plot. So suppose you could see data and its descriptive statistics along with it. Wouldn't that be lovely? So this is the basic joint plot. Look at this. You have horsepower versus miles per gallon. Let me do it like that. Right? This is the main scatter plot that we just made. But what do you notice at the top? You see the histogram, the frequency plot, right? The histograms. Really? What are histograms? That in that region, how many data points are present? The count of data points present in that particular region. For example, in this region, which is in this particular vertical column, how many data points are present? Right? It shows you data density. Likewise, along y-axis, it just gives you a sense of that. So that is the beauty. Joint plots are the power of Seaborn. I always go to Seaborn to get the joint plots. Right? Now you can do more. You can even superimpose something called kernel density estimators, KDEs. Now, and this will make sense only for those who have done machine learning classes with me. So guys, do you remember that I said that you can fit a regression line to the data, or regression curve to the data? This is XY data, right? You can fit a regression plot. And the beautiful thing with Seaborn is that you get that free. You just have to say, let me just show you the one little keyword. Lowest is equal to true will immediately fit a regression curve through the data. It uses a particular algorithm, right? It's a locally weighed regression, right? It will do that, lovely. And not only that, do you see that there's a line over the histogram? This line is called a kernel density estimator. It is a more smooth representation of how dense data is in the regions. Kernel density estimators is a whole topic. We are going to do it more properly. 1 second, guys. Sure, I'm wrapping the class. Let me call you in a bit. So it gives you a sense. We'll have a whole notebook on kernel density estimators. It's 6 o'clock. Going to be 6 o'clock, so I'm winding up. By the way, how many of you are ready to stay for another 2 hours?
I don't think I can do it.
Okay, all right, it's getting late. We will break it up. But next Saturday we'll cover. And guys, remember, I have moved a little fast towards the end to cover enough material. But remember, we are available Monday to Friday. Please reach out to us in the evenings. And throughout the day if you want, whenever you want. But there will be regular sessions every evening, and we are available for helping you throughout the day. Right? Take our help in understanding, and if you need explanations of some piece of code in this. So this is it. You can change the number of bins. You know, this is a finite number of bins, whatever it is, 1, 2, 3, 10 bins or 15 bins. You can choose the number of bins. You can play around a little bit with it. You can see I increase the number of bins, right? It looks better representation of the data. You can do all of that. So the way you think about this is that this is the main plot, the joint plot, right? And these are called marginal plots. The word comes from statistics. Whenever you have two-dimensional data, if you project it along only one axis, how does the data look? And if you project it against the other axis, how does the data look? Those are called marginals, right? The word comes from spreadsheets. If you look at financial spreadsheets, in the margin means, for example, in the right margin, you can add up all the values in the row, all the column values of the row, right? So for example, if the rows are days of the month and the row is about how much, I don't know, money you made from shoes, right? So that row's total would be the total money you made from shoes in that month, isn't it? You write it in the margin, or the rightmost column typically, or in the margin. That's from there comes the word marginal. Are we together? That's it. So this is these two are what are the marginals? This marginal and this marginal. A top marginal, right marginal, main plot, joint plot, right? So that's how you think about it. Now, you can get fancier, but suppose you feel this is not powerful enough. Let's look at what we are trying to do. Aha, do you see there's a lot more happening here? We have not only the histograms, but we have put something called the rug plot. What is rug plot? Every place that you find a data, you draw a line along the x-axis. But at the top, every place that you find a data, for example, there is this data here. So if you go up, you find this data point. You see this vertical line here, right? Observe where my mouse is. Is my mouse visible? Right. So
Yes.
This line corresponds to this data point, right? Likewise, here there are two data points. So you should see things pretty close by. So like this, and then here also. So this point corresponds to this. The whole density of points. So this is the rug plot. Now, what is this background shading? It is like, gives you, these are called kernel density estimators. They give you a sense of how dense a region is with respect to the points, right? Like in this case, the deeper the blue, the more dense the clustering of points there is, right? I hope this is apparent by looking at this figure. Right? Now, you could go about this far using this joint plot syntax. And this is, by the way, this joint plot is an excellent thing to cover during the week and ask for help in understanding it. So let's think about it. In the joint plot, we first draw the main plot itself, the data, the scatter plot, right? Then we add a kernel density estimator. Do you see we are layering in kernel density estimators are this blue, blue ink, light and dark blue ink, right? They are the kernel density estimators. We added that on top of just this basic thing, and Loess and all those true. Then we do one more. We say, hey, let's add all these rug plots also. So you can go on layering things on top of each other, right? So this is the rug plot. These are called rug plots, right? And now, if you look at this data now, would you agree that it is a far more informative than just a scatter plot? It gives you some statistical description of the data, a feel for the data. Would you agree, guys?
Yes.
Yeah, that is it. Huh? But then suppose you need even more power. Then what happens is that the joint plot internally has something called the joint grid. You have to go down to the primitive of joint grid. Joint grid is that the moment. So let's create an empty joint grid with horsepower and miles per gallon. If you create it, you get this outer template, right? Which is what you're seeing here, center, top, right. Do you see this? Center, top, right. Center, marginals, top marginal, right marginal, right? Now we can choose what to do with each one of them. You can say your data, the same thing, joint grid. In the center, you happen to choose to put the scatter plot. And this is it. And scatter plot here, this is the data. This you do. What happened? Now let's look carefully. You're seeing data X is horsepower, Y is this, size is based on cylinders. Hue, color of the plot is based on weight. Now we have recovered the graph that we made a little while ago, right? Is this graph looking familiar, guys? Right? We have drawn this, there's nothing magical about it. This is it. But you have to specify where are you putting it. Axis is where. You're saying it is in this one. This axis is called ax joint. This is a joint plot location. So you plotted this part. You say, all right, good. I got this one right. Now let's put something on the sides. Oh, but let's just focus on the center itself. You say, all right, let me put kernel density estimators along with contour lines, contour curves. So the same code from here to here remains the same. Now you add the contour plots, kernel density estimators, KDE plots. You do that, and we choose a midnight blue color, etc. And it has some properties like alpha and how many lines, how many levels into which density is broken up into, and you still stick to the center. When you say shade is equal to false, it will make the contour lines, the edges. And when you say shade is, if you don't say shade is equal to that, if you instead say KD is equal to true, it will do the shading, right? So what we should end up with is, and then you do the histogram. Where do you put the histogram? On the Y margin, up margin and the X margin here, right? So you end up with, so do you see how systematically, piece by piece, you're layering this together? You made the first scatter plot, then you put contour lines here, then you put rug plots, then you put histograms, then you put KD, kernel density curve on top of it, right? But do you realize that if you go systematically, no one part is hard? Would we agree on that before we close today, guys? That now, at least this part begins to look very simple, isn't it? Right? Very simple. And this KD is exactly this, except that it plots, not scatters the points, but it plots the density plots, contour lines. This is the histogram at the top, histogram on the side. And we add rug plots also. All of them have just some very basic attributes, right? Do you notice that I colored this salmon and this midnight blue? Where is that? Let's go and see. Look here. Midnight blue is the one which the Y margin means this guy. And this is the X marginal, because if you project the data along the X axis, it becomes the top marginal plot, right? And so you end up with this particular visualization, which I hope you appreciate the beauty of. It looks beautiful, isn't it? Right? That 10 minutes I have, I'll take that actually to show the same thing using Altair. So guys, so the lesson to take away is Plotly is beautiful. It gives you nice interactivity. Matplotlib gives you a lot of power. You can keep on doing things, but takes longer. Seaborn is very powerful when it comes to joint plots, right? Joint plots is its like best foot forward. It's a shining star of Seaborn, in my view, right? You cannot create this kind of a plot as easily with any other library. And the beautiful thing is because Seaborn is sitting on top of Matplotlib, it is basically Matplotlib. You can go on adding things to it. All the power of Matplotlib is still accessible to you. Right? Go ahead, Albert.
So these colors, can you change them, or is it
Oh, very easily. Go and change whatever. What do you want to change?
where do you put the colors, or you have the midnight blue?
Yeah. You see the colors, right?
Oh.
Go put whatever you want, right?
So it's all your artistic thing that has come out, right? So if you do it, maybe ugly.
No, you'll get the hang of it. See, here's the thing. When you don't know colors, use color map. Because great people have thought deeply and given you a palette. Use that palette, right? I don't know why. When I was a kid, I used to make paintings, and my trademark was my skies would be purple and red, right? You know, very, very strong, vibrant colors. So it's always been like that with me. So, well, there it is. So this is that. I would like to do this thing with Altair now. And we have only about 10 minutes, so I'll be quick and show you, just run through this. All the data is still the same, auto data, this, that. Scatterplot with Altair, very simple. By now you're used to. Remember, the only difference between a bar chart and scatterplot is there, the aesthetic was, the unit of was what? Bar, mark bar. Do you remember that in bar charts, we used to do mark bar? Do you remember, guys? But here we do mark circle because we want to put circles all over the page. That is it. The rest of it, I hope, looks exactly familiar, nothing unique. Encoding X and Y axis, horsepower and MPG, and then you tell that both are quantitative measures. So far, so good, guys. Right? This is it. We can do, and then we can apply a dash of style and all that we have been doing. Right. So all of those things, change the width, give why 800? It is better with 1000, but okay, I'll leave it as that, and more information. So I'll have to run this because Altair won't accept. Let me make it trusted. This is Jason, yeah. Let me reload. Oh, there it is. Okay, so I had to mark it. So here's the thing. This is it. Now notice that when you make a chart like this, this is Altair, you can save it as SVG. Now remember, guys, any figure that you can save as SVG is gold. Why? Because you can scale it up. You can make it the size of a billboard and paste it on the side of a building. And it will still look pretty, right? It won't pixelate. So SVGs are actually the right way, I would suggest, to do that. And you can open it up in Vegas. Remember, you could Vega editor and you can do that. Apply a dash of style. The same thing, remember, we now changed what? Make it a little bit more transparent. Where's the style? Here's the style. Do you see this? So these are the stylistic elements. Pick a color, salmon, opacity. You know what opacity is, right? The stroke white means that give it a little bit of a white edge. Yeah, that is it. Then add more information with this. Remember, you can use color to add information. What are we using color to add information about? Let's find out. Color. We are using weight for color. Isn't it? What happens? Look at this. Heavier vehicles are color coded. In this particular case, we used a color map, yellow, orange, red. You can change it to any of the color maps. Right? Looks good, guys? No. It conveys some meaning, isn't it? Heavier vehicles are here. Horsepower. Now, discrete unordered color scale, for example, if you are trying to do origin or something. Oh, by the way, one of the things people do is, one of the color schemes, because Tableau is used so often, people say, oh, but it doesn't look like Tableau. Yeah. Tableau color scheme is supported, is actually in the open source. It is there in every library. So you want to make it Tableau-like colors, you just say color scheme is Tableau. Tableau, by the way, is a popular GUI tool to make plots, etc. if you don't know programming, right? So here it is, guys. Do you notice that it is now following, you don't know, but it's following the Tableau color scheme. You can add more information by size. Remember, we just use the color, but size is still in our hands. We can say, there we go, x-axis scale. Then you have to say from what to what, because you don't want the sizes to just blow up. So you can give a little bit of a size thing. So now, do you see that these bubbles are bigger? Right. Then you can add annotation. Again, nothing new, just the way we did before. Annotations. Its support for annotations is not that great. There is no lovely arrow or anything. You can circle a region and it will help you put a text there in Altair. I'll leave it as an exercise for you to get that kind of lovely annotations that we did with other libraries. You can add tooltips. How do you add tooltips? Just one-liner. Do you see? The tooltip should contain these 4 attributes of each point. Right? So let's do that. Let's see, does it? Do you see the tooltips, guys? It is the 4. Where is it coming from? From just this line of code. Then, notice that these plots are not interactive. I can't zoom in or do anything. Now, what will make it interactive? All we need to do is this, dot interactive. Isn't that lovely? Right? And so what happens? Look at this. Now I can interact with it. I can zoom into it, zoom out of it, move it around. So the interactivity is here now. Right? And you still have the ability to save and so on and so forth. Right. Now, the same thing, the fact that we did intervals, so one of the things that people want, which is very good about Altair, is suppose you want to make a plot and on the right hand side, you keep the zoomed version of the plot, right? Do you notice that as I zoom in, what do you see on the right hand side? The zooming happening here, the window, isn't it? Right? Dynamic zooming, right? And so there is a bit of code because we are over time. We can either do it in the week sessions or you can study the code. It's very easy. We have commented it very well, hopefully. So let me give you an idea. First of all, you capture the extent, like how far along is the region that you have. Then you make the base plot. Remember, this is the plot that you made. Right? And then the left chart is this chart. Nothing special here. The right chart is based on the zooming of the left chart. Zoom. So how does it work? All you have to do, remember, scale from where to where. Extent is the X extent and the Y extent that you capture from the mouse. That's all. Yeah. And you are saying main and zoom properties are this, and there you get this beautiful zoom chart in Altair. I think this is very nice. How many?
Can you in the zoom show some other properties on there?
Oh, yes, yes. You can play all sorts of games. It's interactive. Remember, the whole power of D3 is accessible to you. Right? The faceted charts, different facets of that, right? Remember, we were doing that, right? This code, see, one of the things is we have laid the code out simply so that it's easy to read, right? But it looks long because of that. But each element would be easy to read because you see the bins, 20 bins and so forth. So the join plot, they call it the faceted plot. We have tried to recover it with Altair. And when you do it with Altair, see how many more lines of code it is. It is easy code, but it's still a lot of code. So what do you see? That if you had to draw this, which would you use, Seaborn or Altair? Seaborn, right? That is it. Yeah. And that is it. It is good to know all the libraries, guys. Don't limit yourself to only one. You'll develop a tunnel vision, right? These 4 libraries are the best of the breed. Learn it. right? And of course, if you are willing to venture into JavaScript, then pick up D3. Now, there was a time when I would insist that everybody should know D3, but now it's not really all that necessary, because with the presence of Vega and Vega Lite, you can do things more efficiently in these, and most of the things you will do, you can do it. But because you can use Vega using Altair and you can use D3 using Plotly, your first reaction should be this: can I do it with Vega? Can I do it with Altair, Plotly? Right? If I can't do it, then go one level deeper. No, Altair, Plotly couldn't do it. Let me try it with Vega Lite. If I can't do it, then finally I go to D3 and write code in D3. Right? If you are looking for interactive plots, if you're just looking for static plots, then you can just stick with Matplotlib and systematically build it up. It will take you time, but you'll get there.
But you wouldn't suggest that for Matplotlib and C++. You say learn Matplotlib.
Must learn Matplotlib.
Must.
Must learn, because it's the ubiquitous library. Otherwise, you won't be able to even read most of the code that people write in the data science place, right? Because they generously sprinkle their notebook with Matplotlib most of the time. Yeah. But you realize that most people only know one library. And that also they know because they're copy pasting from the textbook or somewhere else, because that code looks ugly. Just go to Kaggle and see how those plots look compared to the kinds of plots we make. I hope at the end of the day, you realize that if you did review the material today, you will never make the kind of ugly plots that sort of proliferate throughout the web. And all of this Kaggle and whatever Medium notebooks, etc. You can do better, right? You can make beautiful visualizations. So do that.
So as we talked about JavaScript and D3,
Yes.
could you elaborate a little more? What is this JavaScript?
See, the Michael Bostock created the grammar of graphics in JavaScript. Because JavaScript was taking off, everybody wanted to converge on JavaScript. Google was spending a ton of money to accelerate JavaScript, right? There was a huge momentum behind it, and it paid off. Today, Node.js and JavaScript and Angular and React have taken over the world. And the visualization library in the JavaScript world is D3, Michael Bostock's. Yeah. In fact, I would say that in the open source community, it is the most powerful library, which is why in Python, there has been quite a few efforts to layer on top of D3 and Vega.
Okay.
That's it. That's pretty much it.
I'm pretty decent in JavaScript, so should I spend some time on that?
On D3, yeah, definitely. But before you do it, remember, escalate it slowly. First master Vega Lite instead. Once you, because it's quicker. Any one thing you want to do, if you can do it in, see, here's the deal. If you can do it in Altair, it is the shortest lines of code. It will produce Vega Lite code for you. And therefore you can put it in your web page. If Altair cannot do it, then you go to Vega Lite and handwrite Vega Lite. If that also doesn't work for you, now is the time to go into D3. Right? So you should escalate gradually, right? Otherwise you waste a lot of tool. It's like, I really know how to build a web, browser. So every time I want to design a website, I'll start with C code and write a browser, and then with the browser pointed to web pages. It doesn't make sense, right? All right, guys. So with that, I'll end today. I hope you had fun. I will post all of these notebooks within a couple of hours. I'll take some rest, and after that, I'll post the notebooks. Kyle and Kate and Harini, thank you very much for staying up and helping everyone.
Sure, sir.